Greetings, I'm Dev the developer.
And I'm Glitch.
You have been writing CSS for a while now, and at some point you have probably stared at a rule that should be applying and watched it do absolutely nothing. Today, we are going to talk about the Cascade, the system the browser uses to decide which rule wins when more than one of them is targeting the same element. 3 factors applied in order. Once you see how they work, every unexplained CSS mystery becomes a solved problem.
Okay, I want to style a page, something I am actually building, a network status dashboard.
Good. Start with the HTML. Keep it simple for now.
Alright, I want the status notes in a muted purple. Easy enough. Good, both paragraphs are purple. Now I realize I also want to write a rule targeting that status note class specifically, because later I might want to style status notes differently from other paragraphs. Okay, both paragraphs are now the lighter color. The class rule is winning.
Is it winning because it came later or because of something else?
I assumed it was because it came later. The second rule overwrites the first.
Swap the order. Put the class rule first.
The paragraphs are still the lighter color. The class rule is still winning even though P comes after it now. That is not what I expected.
So order did not decide it.
Right, if order decided it, P should have 1 because it comes last. But dot status note won no matter which position it was in, so something else is going on.
The browser scores every selector before it even looks at order. That score is called specificity, and a class selector scores higher than a type selector every time.
Wait, so there is actually a scoring system, not just last rule wins.
Last rule wins is the tiebreaker. Specificity runs first. Think of it as a 3-slot counter. The first slot counts ID selectors. The second slot counts class selectors, attribute selectors, and pseudo-classes. The third counts type selectors and pseudo-elements.
So P is one type selector. That is 0, 0, 1.
Right.
And dot status note is one class selector. That is 0, 1, 0.
Now compare them.
0, 1, 0 versus 0, 0, 1. The class wins because its second slot is 1 and P second slot is 0. The third slot does not even matter once you find a slot where they differ.
The slots are read left to right. The leftmost difference settles it. The remaining slots do not participate.
So it is not like adding up points. It is more like comparing version numbers. 100 beats 09999 no matter what.
That is exactly how to think about it. One ID beats any number of classes. One class beats any number of type selectors. The columns do not bleed into each other.
Wait, so what is in that first slot? IDs? I have not used an ID selector in CSS yet. What would that look like?
An ID selector uses hash followed by the element's ID attribute value. Hash hero would match ID equals 0.
And that scores in the first slot, so it beats classes.
Add an element to your HTML, give it an ID and one of the existing classes, then we can test it.
That third paragraph has both the status note class and the alert ID. The class rule would set it to the lighter color. I want to write an ID rule that sets it to something visually distinct. A warning orange maybe. The third paragraph is orange. The first two are still the lighter color from the class rule.
What is the specificity score for hash alert?
1 ID, 0 classes, 0 types, 100.
And for dot status note?
010, so hash alert is 100 versus 010. First slot 1 beats 0, hash alert wins.
Now do this. Move the hash alert rule above the class rule before everything.
Still orange, the ID rule still wins even though it is first now. So specificity genuinely does not care about order.
Order only matters when specificity is tied. Specificity is the first question, order is the fallback.
Okay, so the browser is not reading the style sheet top to bottom and giving the last rule the win. It is scoring every rule, and then if there is still a tie after scoring, then the later rule wins.
That is the full picture for the style sheet case, and explains a lot of bugs that seem random. The rule you wrote later is not winning because the browser forgot about the earlier one. It is because the earlier one outscores it.
So every strike through I see in the browser dev tools is a rule that participated and lost the specificity comparison.
Exactly that. When you inspect an element and see a property with a line through it, the browser is telling you this rule was found, it was evaluated, and it lost. Something else scored higher or tied and appeared later.
That is actually really useful. I always thought those strike throughs meant I made a typo or something.
They are the browser's Cascade report. Every crossed out declaration is a loser in the specificity tournament, and the computed tab shows you which one won. When CSS is not doing what you expect, that is the first place to look.
Okay, so now I want to make a more complex rule. I want to target elements that have both the class and the ID. So not just hash alert, but specifically a P with hash alert, like P hash alert.
Write it. What do you expect the score to be?
1 ID, 0 classes, 1 type, so 101. The alert paragraph is now teal, and the score is 101, which beats 100 from the bare ID rule, even though the bare ID rule came later.
You can stack selectors on the same element to raise the specificity. Each part of the selector adds to its slot.
Wait, so I could write a rule like p.statusNote, and that would be 0 and 1, 1 type and 1 class.
Try it. Write that rule and give it a different color and see which paragraph it applies to and whether it overrides the bare class rule.
The first 2 paragraphs turned green. The alert paragraph did not because it has a higher scoring rule. And p.statusNote is 0 and 1, which beats 010 from the bare class rule, even though the class rule comes before it in the style sheet.
Specificity is cumulative within a rule. More parts means a higher score.
Okay, so I could keep stacking. What is the practical ceiling? Can I always just write a more specific rule to override something?
You can, but there is a trap in that approach. The more specific your rules get, the harder they are to override. If you write nav, ul, li, a for a color on nav links, and then later decide you want a specific link to look different, you need at least 004 to beat that rule, which means you are probably reaching for an ID or adding a class, which then makes the rule hard to override, and so it escalates.
Oh, so the style sheet starts an arms race with itself.
That's exactly what happens in large code bases. People reach for more specific selectors to beat what came before. The baseline keeps rising, and eventually you end up with rules that are nearly impossible to override without a nuclear option.
What is the nuclear option?
Exclamation mark, important. Try it.
Wait, I should probably set up a cleaner demo for this. Let me add one more element to the HTML. Now I want that critical paragraph to always be red. I do not care what other rules exist. I want it red, so I will just use the class and exclamation mark important. That is not actually working because that element does not have the critical override class. Let me just use the existing class and do it directly. Everything turned red. All 4 paragraphs are red, including the alert paragraph that had the ID rule winning. The exclamation mark important on the class rule beat the ID rule.
The exclamation mark important declaration steps outside the specificity system entirely. It is not a high score, it is a different category. The normal specificity hierarchy does not apply to it.
So it always wins.
Almost. What happens if 2 rules both have exclamation mark important and they conflict?
Then specificity between the 2 important declarations, or order.
Try it. Write a second rule with an exclamation mark important on color, targeting the same elements. See which one wins.
The paragraphs are red. The dot status note declaration is winning because it has a higher specificity than the p rules important declaration.
When both declarations have exclamation mark important, you are now inside a second specificity tournament that only includes the important declarations. The same rules apply. Higher specificity wins than source order. But now you have two parallel systems. Normal declarations compete against each other, important declarations compete against each other, an important declaration always beats any normal declaration.
Wait, so I used exclamation mark important to escape the specificity system, and then I ended up right back in a specificity system, just a separate one.
That is the arms race. You cannot escape the system. You can only raise the stakes, which is why exclamation mark important is a last resort, not a solution.
And when would you actually use it then?
Utility classes are the main legitimate case. If you are building a class called visually hidden that absolutely must hide something regardless of context, you want that to be unoverridable by accident. Same with accessibility critical styles. The rule is use it when you genuinely need a guarantee, not when you want a fix for a specificity problem.
Because if I use it to fix a specificity problem, I have not fixed the problem. I have just buried it under a bigger exception.
And when you need to override that exception later, you're stuck. So let me reset the demo to something saner. Take the important declarations out.
Okay, back to the normal cascade. The alert paragraph is teal because p#alert is 101, which beats everything else. The first two paragraphs are green from p.statusNote at 011.
Now, the last piece. There's one more thing that outranks even ID selectors in the normal cascade. The inline style.
Wait, I thought ID was the top of the scoring system.
ID is the top of the selector system. An inline style is not a selector at all. It is written directly on the element in the HTML with the style attribute. The browser treats it as having a higher specificity than any selector you could write in a style sheet.
So the selector system and the attribute are in different categories.
Think of it as a fourth slot to the left of the ID slot, 1000 for an inline style. No selector in a style sheet can reach that. Try it on your alert paragraph.
I will update the HTML. The alert paragraph is now orange, not the teal from p#alert, not the green from p.statusNote, not the warning color from #alert. None of the style sheet rules beat the inline style.
The inline style wins because of where it lives, not because of a score. It is the most direct possible targeting. The selector system exists to reach into the document from outside. An inline style is already there.
So the full order from lowest to highest is type selectors, then classes, then IDs, then inline styles.
With source order as a tiebreaker when specificity is equal, and exclamation mark important as the override that sits above the whole normal chain.
Wait, so how does exclamation mark important interact with inline styles? If I put exclamation mark important in the style sheet, does it beat an inline style?
It does. That's one of the legitimate uses for it. If a third-party library or a CMS is injecting inline styles you cannot control, an important declaration in your style sheet can override them.
So the hierarchy is normal inline beats normal style sheet rules, but important style sheet rules beat normal inline. And then important inline beats important style sheet rules.
You now have the full model. Important inline is essentially the ceiling. Very few legitimate reasons to ever be there.
Okay, so let me actually think through what this means in practice. I have a style sheet that is getting complicated. Multiple rules targeting the same elements. I keep writing more specific selectors to override earlier ones. At what point should I just stop and rethink the structure?
The warning sign is when you find yourself writing a selector specifically to beat another selector rather than to describe the thing you want. The selector should say something true about the element. This is the P inside the nav, inside the header is a description. I need something that scores higher than 0 to 1 is not.
So the goal is to keep specificity as flat as possible. Classes for most things, IDs only when you genuinely mean one unique element.
That is the approach most experienced CSS developers settle on. Keep specificity low and consistent, and source order becomes a predictable tiebreaker instead of a source of bugs.
Wait, so can I ask about something I saw? Sometimes I look at a style sheet and there are rules using the star selector, just a bare star. Does that have a specificity score?
0 across the board. The universal selector contributes nothing to specificity. A rule like asterisk P has the same specificity as P.
So star is the one selector that does not cost you anything in the specificity account.
Exactly, which is why it's used in resets. No specificity overhead, applies to everything, wins nothing.
That's actually a very elegant design decision. You can write a blanket rule without accidentally raising the baseline for every element.
Now, let me show you one more thing that trips people up. Combinators.
Wait, combinators have a specificity score.
The combinators themselves do not. The selector components they connect do. Write nav A and you have one type selector for nav and one type selector for A. That is 002.
So I could write a very long selector and stack up a lot of type specificity.
You could. Header, nav, ul, li, a is a 005, which sounds powerful, but any class selector on that A element would beat it. 010 beats 005.
Oh, so long descending selectors are weaker than a single class, even if they look more specific.
They look specific in terms of targeting, but the score says otherwise. This is one reason why heavy reliance on deeply nested selectors creates unpredictable results. They feel precise, but they are easy to override with a simple class.
So being precise in terms of structure is not the same as being precise in terms of specificity score.
Those are different axes. Structural precision is about which element you're targeting. Specificity score is about how hard that rule is to override.
Okay, I want to run a quick experiment. I know that p.statusNote is 011. What if I write section p.statusNote? That would add another type selector so it becomes 012. Would that beat my p-alert, which is 101?
Work out the comparison.
Section p.statusNote is 012. P-alert is 101. First slot 1 versus 0. #alert still wins. The ID in the first slot kills it immediately.
No matter how many type selectors you stack, you cannot beat a single ID. The column never carries over.
Right, 012 is 0 in the first slot. 101 is 1 in the first slot. The comparison stops there.
Which is why experienced developers avoid IDs in CSS. They create a floor that classed rules can never. Which is why experienced developers avoid IDs in CSS. They create a floor that class-based rules can never reach. If you use an ID selector for styling, any future attempt to override it requires another ID or an important declaration. The flexibility you give up is rarely worth the specificity you gain.
So IDs are fine in HTML for linking and forms and JavaScript hooks, but in CSS they are a liability.
That is the general consensus. Use IDs in HTML as functional anchors. Reserve selectors in CSS for classes and type selectors. Keep the specificity floor low.
Wait, so if I am inheriting someone else's style sheet and there are ID selectors all over it, I am basically trapped. I cannot write a rule that overrides those without matching or exceeding their specificity.
Unless you write a new rule or use !important, which brings you back to the arms race. That is why specificity management matters from the start. It is very easy to write yourself into a corner.
Okay, so I have an ID that I genuinely cannot get rid of. It is on an element that a JavaScript library puts an ID on automatically, and my style sheet does not control it. I want to override the style the library set with its ID selector. What do I do?
You match it. Write your own rule with at least the same specificity as the library's rule. Place it after the library style sheet in the document.
So I write my own ID selector targeting that ID after the library loads, and source order gives me the win if we tie on specificity.
That is exactly the pattern. Source order is the tiebreaker, but only when scores are equal. If the library uses an ID rule and you use a class rule, source order does not help you. You need to match or exceed the ID score.
And if I cannot match it without making my own code worse, I fall back to exclamation mark important.
That is a legitimate case for it. You are dealing with specificity you cannot control and you need a genuine override. Just understand what you're committing to. That declaration is now very hard to override from your own code without escalating again.
Okay, wait, I want to make sure I have the full picture of source order right. Is it just about position in the style sheet, or does it matter where the style sheet itself is loaded?
Both. The cascade considers the entire chain. A style sheet loaded later in the HTML file has a lower cascade priority than one loaded before it, all else being equal. Within a single style sheet, later rules win ties. If you have two style sheets and they both contain a rule with equal specificity targeting the same element, the rule from the later style sheet wins.
So the order of the link tags in the HTML head matters too.
It matters. Your own style sheet should usually load last after any third-party or reset style sheets. That way, when you write a rule that ties on specificity with a library's rule, yours wins by position.
That is why reset style sheets are always loaded first. If they loaded last, they would clobber your rules on specificity ties.
Exactly. A reset style sheet is designed to have lower specificity, but you still want it early so your rules can overwrite it. Order and specificity are both part of the game.
Okay, so now I am going to see if I can describe the full cascade algorithm from memory. There are origins. Inline styles are highest in normal flow. There are selector scores in 3 slots, IDs in the first, classes and pseudo-classes and attribute selectors in the second, types and pseudo-elements in the third. Source order is the tiebreaker. An exclamation mark important creates a parallel tournament that beats normal declarations.
There's a detail worth mentioning. Pseudo-class selectors like :hover and :focus count in the class slot, not the type slot.
Wait, so :hover adds to the second slot, not the third.
:hover is not a type selector. It is not matching an element by its tag name. It is matching a state. States go in the class slot.
So a :hover is 001 for the a type selector plus 010 for the :hover pseudo-class. That is 011 total.
Correct. And that means a :hover is more specific than a bare A rule, which is usually what you want, because you are deliberately overriding the default link style for the hover state.
So if I write a rule setting color to blue and then a :hover rule setting color to red, the hover rule wins when the link is hovered not just because of source order. It also scores higher.
Both work in your favor on that one, higher specificity and later in the source. That is why the pattern works so reliably. If you accidentally put the hover rule before the normal rule, the specificity advantage keeps working. The pseudo-class counts.
Wait, so what about pseudo-elements, like : before, that goes in the third slot with type selectors?
Pseudo-elements go in the type slot. They're treated like element selectors. P: before is 002. One for P and the other one for : before.
So pseudo-classes are in the class slot and pseudo-elements are in the type slot. And the way to tell them apart is the : versus the single colon.
That is a visual distinction, yes. Single colon is a state or condition. Double colon is a generated element.
Conditions are like classes. Generated elements are like types. That actually makes sense as a categorization.
It does. The people who designed the specificity system were being consistent about which each category means. About what each category. The people who designed the specificity system were being consistent about what each category means.
Okay, I actually want to test something that is going to hurt me and I know it. I want to write the most complicated selector I can and see what the score is.
Go ahead.
122, I do not think I need this rule, but I wanted to see what that felt like to compute.
And that selector is now extremely hard to override without an important declaration. The ID in the first slot means anything you write without an ID or important will lose.
Yeah, I am not going to use this, but now I understand why you would never want to write something like this in production. You have locked yourself into a corner from one rule.
The practical takeaway is to keep specificity as flat and consistent as possible. Write your selectors to be just specific enough to do the job. Save IDs for HTML structure in JavaScript. Let classes do the styling work.
Okay, wait, can I go back to source order for a second? Because I want to make sure I understand when it actually matters versus when specificity just decides everything before we get to order.
Source order only matters when specificity is exactly equal. Write two rules with the same score targeting the same element and the same property. Then order decides.
So in practice, the main place source order shows up as the real deciding factor is when I have two class rules with no additional selectors on them, and they both match the same element.
That is the most common case. Two classes, both 0, 1, 0, both targeting the same element. The one later in the style sheet wins.
And this is where people sometimes get confused and think the order of classes in the HTML attribute matters. Like they think if they write class equals status note critical versus class equals critical status note, it changes which style applies.
It does not. The HTML attribute order is irrelevant to CSS. The Cascade looks at the style sheet, not the attribute.
Oh, I have definitely been wrong about that. I thought the last class in the attribute won, but it is the last class rule in the style sheet.
A very common misconception. The class attribute is just a list of labels the browser uses to find matching rules. Once the rules are found, the Cascade takes over. The attribute order is invisible to it.
So if my style sheet has critical before status note and an element has both classes, status note wins, no matter what order I write them in the HTML.
Exactly, which means you can control which of two equal specificity rules wins by controlling their order in the style sheet, not in the HTML.
That is going to make me recheck about 6 rules I wrote thinking order in the attribute mattered.
That is the right instinct. Go check them.
Okay, but first I want to ask about one more thing. What happens with inheritance and the cascade? Like if an element has no matching rules at all, it inherits from its parent. But what if it has a matching rule and an inherited value? Does the rule always win over the inherited value?
Yes, any explicit rule targeting an element directly wins over an inherited value. Inheritance is the last resort. If nothing matches the element directly, it inherits. If anything matches, that match wins regardless of specificity.
Wait, so a type selector with score 001 on the element itself beats an ID rule on the parent because it is a direct match versus inheritance.
That is correct. The Cascade operates on direct rules. Inheritance fills in the gaps. Direct always beats inherited. Think of it as inheritance living below 0 in the stack. Any direct match, no matter how low the specificity, outranks any inherited value.
So the cascade runs first, and only if nothing applies directly does the browser reach for the inherited value.
Right. The Cascade is for competing direct rules. Inheritance is for when there are no direct rules. They operate at different stages.
That is why overriding typography on a specific element works even with a bare type selector. You are not competing with the parent's rule in the cascade. You are just providing a direct rule where none existed before. The cascade does not even involve the parent at that point.
The cascade is always per element. Two rules competing to style the same element. The parent's rule is not competing for the child. It's only relevant if the child has nothing of its own.
That clarifies so much. I was thinking of it as the parent's rule and the child's rule battling in the same cascade, but they are in different cascades. Each element runs its own.
Each element has its own cascade. Parent values arrive through inheritance if and only if the element's own cascade produces nothing for that property.
Okay, so the full picture, each element runs its own cascade. Step 1, gather all direct rules that target this element. Step 2, sort by specificity, highest wins. Step 3, ties broken by source order, later wins. Step 4, inline styles are in a category above any stylesheet selector. Step 5, exclamation mark important declarations live above normal declarations in their own tournament. Step 6, if nothing matched directly, check if the property inherits and look at the parent.
That's the algorithm. You just described what the browser does for every property on every element on the page.
That's actually the fact that browsers do this for thousands of elements with hundreds of rules in milliseconds is genuinely impressive.
It is, and it is optimized heavily, but the logic is exactly what you described. Nothing in that sequence is arbitrary. It is designed decisions all the way down.
Wait, cascading style sheets. The cascade is literally in the name. I never thought about why it was called that.
The cascade is the whole game. Style sheets are how you write the rules. The cascade is how they are resolved. The name is describing the most fundamental behavior.
So all this time CSS has been announcing exactly what it does in its own name, and I just did not notice.
Most people don't. They learn the language long before they learn what the name means.
I want to think about what cascade is actually a metaphor for here. Water cascades downward, later positions win gravity. Rules cascade through the stylesheet, later rules have the final say when scores are tied. The metaphor is pretty direct.
It is, and important declarations are like a dam. The water cannot flow past them without being redirected.
That is actually a better metaphor than I came up with.
This is the part where it stops being scary. Every time a CSS rule did not apply and you had no idea why, it was one of these three things. Higher specificity one, source order broke a tie, or an inline style or important declaration overrode everything. The styles did not misbehave. The rules were being followed, you just didn't know what the rules were yet.
Every CSS mystery I have ever had, it was always one of these, I just could not see it.
Which is why the dev tools exist. Open them up on something that is not working, look at the crossed out declarations, look at what scored higher. The browser is showing you exactly who won and why.
And now I know how to read that report. Every strike through has a reason. I just have to find the rule that beat it and check the score.
Open up a style sheet you have written, find a rule that lost a conflict, work out why it lost by computing the specificity scores yourself. Then check your answer in the dev tools. The practice makes the system automatic. Don't just watch it, do it.